Hello everyone and welcome to my channel. Today's video we're going to dive into an intriguing concept in the fluid dynamics known as the mass conservation equation. Now you might be wondering what exactly is the mass conservation equation. It's the blue framed equation you can see here. Simply put, the mass conservation equation, also known as the continuity equation, is a fundamental principle in fluid mechanics that states that mass can neither be created nor destroyed in an isolated system. It describes how the mass of a fluid is conserved as it flows through a given region, like the little domain here. For instance, to understand this equation, let's break it down. It consists of two essential components: the rate of change of mass within controlled volume and the net mass flow rate across its boundaries. Mathematically, it can be represented as the derivative of rho with respect to time plus the gradient operator nabla applies to rho times v equal to 0, where rho represents the fluid density, t is the time, v is the fluid velocity, and nabla applies to rho times v is the divergence of the mass flux vector, so sum of the partial derivatives. The first term on the left side of the equation, that is to say the derivative of rho with respect to time, accounts for the change in density with respect to time. It captures any variations in the density of the fluid within the controlled volume as it moves through time. This second term, nabla, applies to rho times the impedance, the divergence, and the mass flux vector, which accounts for the flow of fluid across the controlled volume's boundaries. It describes how the fluid is entering or leaving the controlled volume, thereby affecting the overall mass within it. The mass conservation equation finds wide-ranging applications in various fields, such as fluid dynamics, environmental engineering, and even meteorology. It allows us to analyze fluid flow behaviors, predict fluid concentrations in environmental systems, and understand how mass is distributed within a flow. In summary, the mass conservation equation is a fundamental principle in fluid dynamics that ensures mass is conserved within a system. It provides insights into how fluids behave, and by solving this equation, we can gain a deeper understanding of fluid phenomena. And that wraps up today's video on the mass conservation equation. I hope you found it informative and intriguing. If you have any questions or would like to see more videos on fluid mechanics, let us know in the comments below. Until next time, happy exploring.